Hello students, welcome back to my YouTube channel. This is Kashima Soni and today we are going to start a new topic in the series mass spectrometry, that is mass analyzer. So basically we are going to discuss various kind of mass analyzer over here, and before jumping to that very topic, I would like to make a request to you all. Just check the link that I have mentioned in the description box. I have mentioned all the links that I have already uploaded in the series of mass spectrometry. That includes your introductory portion and your ionization techniques as well. So before jumping directly to this video, I request you to check those videos first and then switch to this part. Okay, and without wasting any more time, let's just switch to our magnetic sector mass analyzer, correct? And that is over here. Okay, so basically we are going to see various kind of mass analyzer that include magnetic sector, double focusing, quadrupole mass analyzer and time of flight mass analyzer. So first of all, we'll be discussing about magnetic sector mass analyzer. Let me show you its diagram first. So this is the schematic diagram of your magnetic sector mass analyzer. And before directly jumping about this particular scheme, I would like to add on one thing over here. See what is happening once your sample is ionized. Okay, आपने अभी तक ionization techniques देखी हैं. आपने क्या सीखा है कि आपका sample कैसे ionize हो रहा है, कैसे वो molecular ions बना रहा है. ठीक है, अब होगा क्या, एक बार आपका सैंपल आयनाइज हो गया, जो बीम ऑफ आयंस है दैट हैज बीन एक्सेलरेटेड बाय द इलेक्ट्रिक फील्ड, क्या होगा, नाउ इट इज गोइंग टू पास इनटू द मास एनालाइजर. और मास एनालाइजर क्या है, इट इज अ रीजन of your mass spectrometer where your ions are getting separated as per your mass by charge ratio. Understanding? So if you want to write down, you can write down over here. Yeah, you can write it over here. Let me just change the color of the pen first. Okay, so you can mention over here, it is a region of mass spectrometer where ions are separated as per mass by charge ratio. Okay, so that is our mass analyzer, and in this particular topic we are going to discuss various different kind of mass analyzer, and the first one being magnetic sector mass analyzer, having the diagram like this. Okay, so that is the introductory portion of what is your mass analyzer. Okay, all right, so okay, let's see what is happening exactly in your magnetic sector mass analyzer. Over here you can see what is happening. Your ions over here, your ions are accelerated so that they all have the same kinetic energy. First thing first, correct? And now what is happening, all of these ions that are being formed in the ionization chamber, they all are accelerated into the focusing beam, and then these ions are deflected by magnetic field according to the mass by charge ratio. Understanding? I'll repeat it for you. What is happening, all of your ions are getting accelerated into the focusing beam, and then your ions are deflected in the magnetic field as per their mass by charge ratio that has already been mentioned over here also. Okay, so what is happening, your magnetic field is perpendicular to the direction of your ionic motion. So you can write it over here separately. You can write over here, magnetic field applied, magnetic field is perpendicular to the direction of your ion motion, perpendicular to the direction of ion motion. So that is how your working of this particular magnetic sector mass analyzer will occur. See what is happening after passing through these two magnets. What is happening, your ions are getting deflected in different position as per their mass by charge ratio. See, if you have a lighter nuclei, what is happening, lighter nuclei are deflected, they are going to have more deflection. Understanding? So over here you can see the lighter nuclei having smaller mass by charge value. What is happening, they have different radii of curvature through the magnetic field as described by the equation that we are going to see in the previous slide. Okay, and that is how you will see the lighter ion are going to have more deflection as compared to your larger or bigger ions. Okay, so that is how the working of your magnetic sector mass analyzer is all about. Proceeding to the particular equation that we were discussing in this very diagram only. See, that has been mentioned, the equation 3.15, that is over here. Let's see what it is exactly. This one is the equation that we have been talking about. See, to derive this equation, we have to see from the starting what is happening. See, if your ion that have already mentioned, your ions are accelerated, so that they all are having the same kinetic energy. Okay, so let's just assume that your ion have charge E and it is accelerated to voltage V. So the kinetic energy of this particular ion is going to be, see, kinetic energy is half mv square, and now it is equal to the charge multiplied by voltage. Okay, so take it as equation 1. Now what is happening, your magnetic field H, it is causing the ions to move in a circular path of radius r. Okay, so you can see over here in that particular diagram, your ions are moving in a circular path like that. Okay, so what is happening, the magnetic field causes your ions to move in a circular path of radius r, and the force of attraction, that is also known as centripetal force, given by HeV. Okay, that is your centripetal force, also force of attraction. It is balanced by the centrifugal force, that is mv square upon r, as per your Newton's second law of motion. Okay, so you can equate this as such, mv square upon r is equal to HeV. Now what you have to do, square both these sides, then you will get your h square e square v square is equal to m square v raised to the power 4 divided by r square. So now what is going to happen, you can write it as this also. V square will cut this to square now, and this is what you are going to get now, this particular equation. See, from equation 1 you can see what you have, half mv square is equal to ev, and you can also write it as, if 2 will go to this particular side, you can write it as mv square is equal to 2 ev. So now you can put the value of mv square over here in equation 3rd, in this one equation. You will get h square e square is equal to m multiplied by 2 ev divided by r square. Okay, that is the value of your mv square. So m you have taken outside, and you have put the value of mv square over here. So after solving this equation, you are going to get this particular equation, that is m divisible by e is equal to h square r square divided by 2v. So this is it is clear from the equation that radius of the ion path, it can be changed by varying the magnetic field at constant voltage. Okay, so if you are going to change the radius of the ion path, you can vary your magnetic field, that is the applied magnetic field, at a constant voltage. Okay, so that is one thing occurring over here. And if you will be increasing your magnetic field, the ions of progressively higher mass by charge ratio attains the necessary radius to pass to the collector slit sequentially. Okay, so if you're going to increase your magnetic field value, the ions of progressively higher mass by charge ratio, they are going to directly pass to the collector slit sequentially. Okay, so that is one thing occurring over here. So that is how we have discussed about your magnetic sector mass analyzer. Okay, so proceeding further without any more delay. So the second mass analyzer over here is your double focusing mass analyzer, having structure like this. This is your double focusing mass analyzer. Okay, just let me go to the previous slide. Yeah, so this is figure 3.12 that you are seeing over here is your figure of your double focusing mass analyzer. Let's see what it is all about. So in case of many applications, much higher resolution is required, and it can be achieved through the modification of your previous magnetic sector design. Okay, so what is happening, in fact, the magnetic sector that we are using today are actually double focusing mass analyzer, having greater resolution as compared to the previous one that we have discussed already. So what is happening, the particle leaving the ionization chamber do not precisely have the same velocity. See, it is not necessary कि जो आपके particles जो आपके ionic form में leave कर रहे हैं ionization chamber को, it is not necessary they are all going to have the same velocity. Okay, so the beam of ion passes through the electric field region before or after the magnetic sector. Now what they are basically saying over here is, let's see the particular diagram. See, what is they are saying, that आफ्टर द फॉर्मेशन ऑफ आयंस क्या होगा कि सभी की, इट इज नॉट नेसेसरी कि सभी के सभी आयंस की आपके सेम वेलोसिटी हो. सो टू अटेन दिस इक्वल वेलोसिटी, व्हाट इज हैपनिंग, योर आयंस आर पासिंग through your ions are passing through your electric field region. Okay, so over here you can see this is your magnetic sector, this is your electrostatic analyzer. So what is happening, your ions are going to pass through the electric field region either before or after magnetic sector. It is not required that it should be passed after your mass analyzer, or it should be passing before your mass analyzer. It is not so hard and fast rule. So it can occur in either way, that your ions could be passed by either through electric field region, either before or after the magnetic sector. Okay, so in the presence of electric field, what is happening, all the particles are now going to travel in the same speed. Okay, now all of your ions that have been formed after, in the presence of your electric field, what is going to happen, they are going to be traveling in the same velocity, in the same speed. So now your particle will be describing a curved path that you can see again. They will be describing the curved path in each of these region of electric field. Okay, and now the resolution is ultimately increased. So over there in the previous design of your magnetic sector mass analyzer, that is this one, we have been discussing just about your magnetic field. Okay, and it is not necessary that all of your electrons are going to have all of your ions are going to have the same velocity, but in the presence of your electric field, they are going to travel with the same velocity, all of your ions. Okay, and which you can detect via electrostatic analyzer, and after the detector you can separate all your ions into your mass by charge ratio. Correct. So that is all about your this particular double focusing mass analyzer. So I'll be stopping my video over here only, and rest of the two different methods of your mass analyzer will be taken up in the next video that I'm going to upload later after. So thank you for watching. Do like, comment, share the link, and subscribe the channel, and do not forget to press the bell icon for more updates. Thank you so much.